Hello, my name is Jeongeun from KSD. Today, I would like to present a research paper on big data and network analysis in national innovation systems, the roles of academia, industry, and government research institutes and their interactions. There are four main things dealt with in my presentation. First, introduction, data and analytical methods used in this research, the results of the analysis, and finally, the discussion and conclusion. Since the introduction of the National Innovation System approaches in the 1980s, various countries have adopted this approach as a framework for researching the fundamental causes of differences in levels of innovative performance, which is bound to have an impact on the long-term economic development of a nation. Although most of this research has been focused on analyzing the national innovation systems of developed countries, NIS scholars have also analyzed the developing countries that have achieved accelerated economic growth, such as South Korea, Taiwan, and Singapore, which are referred to as the Asian newly industrialized economies. South Korea achieved the quantitative growth of its economy with the NIS characterized by strong government influence of R&D investments, imitative R&D led by GRIs, stand for Government Supported Research Institute, and the dominance of large firms in utilizing and disseminating the outcomes of R&D. In the 1990s, however, intensified competition through globalization and the emergence of latecomer developing countries such as China and India made it difficult for South Korea to continue to generate innovative performance through imitative R&D. Furthermore, as large firms developed their own R&D capabilities, it became necessary to restructure the R&D system that had been led by GRIs. In response to these changes, in the 2000s, South Korea redefined its NIS as a system that facilitates the creation, exchange, and diffusion of knowledge among actors, namely academia, industry, and government research institutes, and undertook to build a new NIS. The purpose of this study is to analyze the KNIS stands for South Korean National Innovation Systems in a way that reflects the changes that have occurred since the 2000s. This study is a starting point to analyze the KNIS using big data on national R&D projects and provide insights for policymakers regarding how they build a more effective and systematic NIS. This slide shows the analytical framework used in this study. First, the data on national R&D projects since the 2000s was extracted from the NTIS. As the data on joint research project gathered only beginning in 2012, the data on national R&D projects and joint research projects were adopted from 2012 up to the latest available data period, which covered up to 2016. Next, the data was classified by year and by the main actors that performed the project. You can see main actors in the KNIs here. Table 2 shows national R&D investment classified by main actors, shifting ways from the focus on R&D led by GRIs. South Korea sought to harness the enhanced research capabilities of universities and colleges by increasing investment in national R&D projects, and also cut back on investment in large firms that conduct their own in-house R&D, while actively supporting SMEs to encourage even growth and interactions across actors. Table 3 reports on research project by main actors. Based on the collected data, We examine the Joint Research Network to understand how the main actors in the KNIS create, exchange, and diffuse knowledge as they carry out projects. Before analyzing the Joint Research Network, the hypothesis with regard to whether the Joint Research Project had an effect on innovative performance in the KNIS needed to be validated. It should be noted that we used information on the national R&D performance to analyze the innovative performance achieved by joint research. This is because the NTIS does not separately collect information on the performance resulting from joint research. Therefore, we hypothesized that the performance of joint research will be correlated to differences in the national R&D performance. We then performed Rabin's homogeneity of various tests and validate the hypothesis with Welch's t-test. Finally, we performed social network analysis and modularity analysis on the main actors that conducted joint research project. Tab 4 shows innovative performance from national R&D project. We differentiate between joint research performed, joint research not performed in the years 2012 to 2016. Assessments based on this all indicated that the performance derived from joint research was stronger in comparison to performance from other projects that did not fall in this category. According to the results of the hypothesis test, conducting joint research has an effect on innovative performance in the KNIS as shown in Table 5. Since the premise that joint research affects innovative performance in the KNIS has been validated, we proceed to examine the joint research network to understand how the main actors in the KNIS interact with each other. Figure 2 is a visual presentation of our analysis the structure of the Joint Research Network. The Joint Research Network consists of these individual actors and these relations between actors that propose the joint research and those that receive the proposal. The density was found to be this, indicating low connectivity, which signifies that within the network, there was difficulty in diffusing the knowledge of joint research. Next, the geodesic distance can be achieved with an average length of 7.9 passes and maximum length of 13 passes. By definition, connected components do not have connections with other components, meaning that the overall network is divided into these groups. This indicates that the flow of knowledge has been fragmented. To identify the detailed structural characteristics of the network, we perform centrality analysis, and Table 7 reports the result. The highest share of nodes within the network of joint research belong to SMEs, while the lowest share of nodes belong to GRIs. However, the results were inversed in the cases of the average in degree and out degree centroids. Among all nodes, GRIs ranked higher than other actors in both in degree and out degree centroids. This signifies that in assigning and performing joint research, GRIs were the most active in forming direct relations with other institutions and sharing knowledge. Furthermore, the betweenness centrality of GRIs was the highest among the institutions. It indicates that GRIs were performing the role of a major intermediary, facilitating the transmission of information on joint research among institutions. By contrast, SMEs were found to have a lower degree of centrality compared to other innovating actors. It is logical to assume that the majority of SMEs form one-off relations and have weak influence in the network because they lag in terms of actually creating and exchanging knowledge through joint research. We perform modularity analysis to understand the community structure of the Joint Research Network. Table A lists the top three groups that comprise the largest share of the Joint Research Network. The analysis research who the main centralities of the three groups with the strongest influence on the entire Joint Research Network. In all three groups, GRIs were positioned at the center of the group and led the network, though they had a small number of nodes. The analysis showed that in the reconstructed KNIS, the interactions among main actors have failed to be as active as desired, although such interactions have indeed been proven to generate innovative performance. We argue that four issues can be identified in the new KNIS. First, the interactions among industry, academia, and government research institutes through joint research affects the level of innovative performance generated. Second, the joint research network is currently not structured to optimally facilitate the exchange and diffusion of knowledge. Third, the failure to achieve the desired level of interactions in the joint research network can be attributed to the SMEs, which make up the largest portion of the network. Finally, GRIs, which had a key role in the KNI's prior to the 2000s, have continued to be central in the KNIS since the 2000, despite changes to the system. Based on the analysis of this study, we offer the following policy recommendations. First, policymakers must encourage more national R&D projects to undertake joint research. Second, there must be policies designed to facilitate interactions. Third, to most promote balanced growth rather than reducing the role of GRIs. The government should instead focus on encouraging them to participate in more joint research to expand their exchanges with other actors. Finally, all the large firms and public institutes constitute a small percentage of the total NIS. They generate innovative performance by interacting with other actors and therefore should be given careful consideration in public policy. Our limitation of this study, however, is that it did not take include analysis of diverse factors such as human resources, organization, support system, and culture that affect NIS. Future research should tackle these issues and combine the findings of this study with analysis of other factors that impact NIS as identified in preceding studies. Thank you for listening.